Mars should not look manufactured, but Curiosity found a honeycomb. This is not one cracked rock. NASA says each polygon is only 4 to 8 centimeters wide, yet the pattern spreads in every direction for as far as the rover can see. That scale is the first hard clue. And the mystery. Curiosity met the field while climbing a Martian valley nicknamed Valle Grande. Its cameras built this 360-degree panorama on June 19th and 20th during mission sols 4930 and 4931. The geometry even wraps around Miraflores, a sand-capped butte about 6 meters tall. Curiosity had seen small polygon patches before, but never this scale here. The obvious answer is ancient mud. Some earlier Martian polygons clearly formed as wet sediment dried and split. Curiosity has shown that lakes and streams crossed Gale crater. At Mount Sharp, more than 300 meters of rock began as lake mud. But that explanation is not locked. NASA lists at least 2 other routes to a honeycomb. Repeated warm and cold cycles can stress material until fractures organize. Or burial can compress sediment and squeeze water through it, leaving cracks in mineral boundaries behind. Similar shapes can preserve very different histories. This is more than a strange Mars photo. Drying cracks could record water leaving an exposed surface. Temperature cycles would point to thermal stress. Buried sediment would put moving water below the surface. One pattern, 3 different chapters. Which origin would you bet on? Drying mud, temperature cycles, or buried water? Keep that answer. The chemistry may overturn the most obvious choice. The mission team measured shape and chemistry, but NASA has not announced a final cause. That matters. A clean pattern tempts an immediate label. Science measures, compares mechanisms, then eliminates the failures. Curiosity is built for that test. Roughly sport utility vehicle sized, with cameras, a laser, a drill, and a laboratory inside. Since landing in Gale crater in August 2012, it has read the landscape layer by layer. Those layers have already changed the Mars story. Curiosity found evidence that ancient environments had liquid water, useful chemistry, and nutrients compatible with microbial habitability. It found carbon-bearing organic molecules too. But organic does not mean biological. NASA says those molecules could come from biology or geology, and the rover cannot yet choose between them. The same discipline applies to the honeycomb. No alien builders, no proof of life, not even a confirmed mud crack field. Yet, what we do have is a natural experiment across the horizon. 4 to 8 centimeter cells repeat around a 6-meter butte on a 5-kilometer mountain. The pattern is hand-sized and large enough to surround a rover. Curiosity has been climbing Mount Sharp since 2014 because each layer is a page from a changing climate. Valle Grande adds a new page with an unusual advantage. The same geometry repeats across a huge area. That gives scientists many samples, angles, and chemical measurements to compare instead of trusting one isolated patch. The strongest reversal is this. The honeycomb's importance is not that it looks artificial. It is that natural processes can converge on the same design. The decisive evidence will be the chemistry inside the boundaries, the minerals around them, and how those clues change across the field. So the image is not a solved answer. It is a map of competing histories. Curiosity has spent 14 years proving that Mars was once wetter, chemically richer, and more changeable than the cold desert we see now. This field may reveal how one piece of that world dried, froze, or moved water underground. And until the measurements separate those possibilities, Mars keeps the final pattern, but not the final explanation. For Curiosity's earlier evidence of ancient lakes and streams, watch the related Mars investigation on this channel. Then tell me which mechanism you think the chemistry will leave standing.